Welcome to General In-Situ Data Submission Procedures. I've divided the data submission procedure into 5 steps. First, it's the initial contact with EBAS. Step 2 is creation of files with focus on metadata and assembling the data. Then it's file check and submission of the data. Step 4 is follow-up of submitted files. And lastly, the data is archived and accessible for users. The first step in the data submission procedure is to get in contact with the EBAS team. This can be done either through the Atmo Access Homeless Data Portal or by email to ebas@nilu.no. The Atmo Access Homeless Data Portal serves scientists producing atmospheric measurements from research campaigns and transnational access activities that are not normally included in any data management system or program. Through the initial contact, the data center will provide a station code, a platform code, and a lab code. An example of this is Birkenes. These IDs are used in the metadata of your file later on. Stations and labs that have already reported data previously do not need to contact the EBAS team again and should use the IDs they already have. The next step of the data submission procedure is to create the files. This includes the metadata and assembling of the data. EBAS provides 2 tools to help you on your way in this step. The EBAS data submission manual includes all the information you need to create files. There are templates for specific variables and information about each metadata element. The EBAS IO Python package provides a way to generate files with Python and includes templates for specific variables in Jupyter Notebook. The EBAS data submission manual is a good starting point for creating files, both if you do so manually or if you do it with Python. The data submission manual provides information on frameworks, a getting started guide, templates for different types of data with line-by-line metadata by metadata explanation. Furthermore, it also provides a list of tools used in the data submission procedure, information about standard operating procedures, QA measures, boundary checks, and valid parameters and instruments. For manual file creation, you can copy or download templates and use it directly as your starting point for your file. But it's very important that you walk through all metadata and customize to your station and your instrument and insert your variables and your data. This video focuses on the manual file creation, but if you are proficient in Python, there is, as I said, an alternative to creating files with our EBAS IO Python package. Files submitted to EBAS should be in the NASA Ames 1001 file format. This is an ASCII-based file format with a very long history at NILU. The file format allows us to follow the FAIR principles. On top of the NASA Ames 1001 file format specifications are some EBAS-specific additions and constraints we require to the files. Lastly, the templates show how to create files for each variable. I'll now go through each metadata element that is required for the file, here with the NASA Ames file format specification on the left-hand side, and a template for filter absorption photometer as an example on the right-hand side. First, it's the total number of header lines and format number. The first number is a line counter for all header lines. If you remove or add a line to the header, you need to change the first number. Do not change the format number. Next is several metadata elements. It's the data originator. It's details of the sponsoring lab or organization. Here you should give the lab code given by the EBAS team after first contact. Then it's data submitter's name and project acronyms. Next up is the volume number and total number of volumes. This is not used and is set to 1:1 to satisfy NASA Ames compatibility. Then it's the reference date and the revision date. The reference date is the start point of the time access in your file, and the revision date is when the file was created or last updated. Next up is the time interval between measurement start points. For hourly averaged data, keep it at 1/24. This includes most quality controlled data. If the data has another time interval, you need to change this number. Next up is the description of time unit. There's only one supported description, so do not change it and keep it as is. Then I jump a little bit down and we get to all the dependent variables. This includes end time of measurement, then variables such as pressure, temperature, or humidity, the variables that you have measured and statistics, and flags. In general, you should use the variables that are in the template. If there are any variables that you have not measured, or if you measure more, you need to add and remove here. An example of this is for filter absorption photometers. Depending on the instrument used, you can measure other wavelengths than given in the template. All valid combinations of parameters are available in the EBAS data submission manual. Above the dependent variables are several numbers. The first one is the number of dependent data columns. This is a line counter for the dependent variables, and for the example it's 14. Next up is the multiplication factors, 1 per dependent variable. This is not used and thus set to 1. So if you have 14 rows of dependent variables, there should be 14 ones separated by a space in this line. Lastly is the missing value tag for each dependent variable. This should be at least an order of magnitude higher than the highest expected value for each variable. If you change the dependent variables, these numbers must change as well. Next up is the number of special comments. This is not used and set to 0. Then it's the number of normal comment lines and the normal comments. The normal comment line is used for global EBAS metadata with the syntax of EBAS metadata tag, :value. The last line is often a comment or acknowledgement. The number of normal comment lines are given before the normal comments. In the normal comments, there are several metadata elements to fill in, and now we will go through a couple of them. First off, you have station metadata elements, which includes station code, platform code, go information, latitude and longitude for your station. All this should be given with the initial contact with the data center and should match previous submissions. Then you have component, unit, and matrix. This needs to follow valid parameter combinations, which can be found in the EBAS data submission manual. Then you have instrument metadata, which includes instrument type, manufacturer, model, and so on. And also these need to be defined combinations that can be found in the data submission manual. If you do not find your instrument, you can contact the EBAS team. Then there are several time metadata elements. First, it's the type code, which for hourly data should be TU, time interval uniform. Then you also have period, resolution, and sample duration, which depends on your data and should match previous metadata elements, such as the time interval. There are even more metadata elements. It's the inlet type or description. This should match the matrix element. So if you have matrix PM10, the inlet needs to be a PM10 inlet. Then you have humidity control of the measurement, detection limit and measurement uncertainty, the standard method or standard operating procedures, SOPs, and lastly, quality assurance measures. Currently known QA measures and SOPs can be found in the EBAS data submission manual. In general, if you have the information, you should include it. If you are uncertain about what a metadata element means, you can read up in the EBAS data submission manual or contact the EBAS team. If you do not have the information, you can keep it blank or remove the line. If you remove lines, you need to change the line counters. Some projects and frameworks require certain metadata elements, so if you are part of such a framework, you need to follow those requirements. When the header and all metadata is prepared, the next step is to assemble the data. Assembling the data consists of the start time, which is the independent variable, and all the dependent variables, such as end time, your variables, and flags. For the templates, there is a flag list connected to it, so here you can see which flags are allowed and not. I would also urge you to have a look at the start time and end time format and use this for your file. After your file is assembled with both metadata and data, the next step is to check it and submit the file. This is done through the EBAS Submit tool, which you can find here. The file check system looks like this. You need to make sure that there are no errors, as this is required to be able to submit the file. Some warnings are usually okay, but if you get warnings, you should check them and see what they are, and if you can fix them. After checking for errors and warnings, the tool will plot your data as a time series. So check that the data looks okay, and then you can submit through the button here. Step 4 of the data submission procedure is the follow-up of files. Here we will communicate if we detect any issues, and you can see the progress of your submitted files. The tools used are Mantis, NILU's issue tracker, and a web page where you can see the EBAS data curation status. Mantis looks like this. If there are any issues, you will be notified by email. It's very important to answer all Mantis issues that appear for your data to be accepted. After any issues are resolved, or if you did not have any issues, your data will be archived. We archive all data levels, and quality assured data will appear in user portals such as the EBAS data portal. For some projects, the data will be available through several data portals, such as the ACTRIS data portal as well. Lastly, this is the EBAS team. We are always happy to help if you have any questions, and we look forward to receiving your data.